In the past billion years, Earth has been hit by asteroids, crashed into other planets, and frozen several times. Not to mention it's been ruled by all kinds of crazy life forms. Sometimes it is a wonder that our blue home has survived at all. But if we want to take a dizzying tour through the history of our planet, we will have to go back to the beginning. About 4.5 billion years ago, our solar system began to emerge from a dense cloud of interstellar gas and dust. This cloud collapsed into a rotating disk of matter that became increasingly hotter until the hydrogen fused into helium. And thus our sun was born, and baby Earth was on the way too. After the birth of our star, all the matter at the far ends of the rotating disk began to clump together. These groups would be the seeds for the planets and moons in our solar system. As they accumulated more matter, they grew and became more spherical. Clusters in the coldest regions of the solar system were composed primarily of ice, liquids, and gases. Closer to the Sun, all the rocky material formed the inner planets like Mars and Earth. This young Earth was incredibly volcanically active, spewing gases like hydrogen sulfide, methane, and carbon dioxide. These gases formed the first atmosphere on our planet. The early Earth was also constantly bombarded by large asteroids and comets. And soon, the Earth experienced an even more violent collision. Theia, a planet the size of Mars, crashed directly into our young world. This epic collision tossed chunks of matter around Earth's orbit, and then gravity brought them together into what we now know as the Moon. On this hot, early Earth, there were no oceans. All water existed in the form of gas. But 3.8 billion years ago, our planet cooled enough for water to condense and turn into liquid. The first primeval ocean covered this young Earth and turned it into a water world. H2O is an essential ingredient to create living beings. So, with all that water, life appeared on Earth about 3.7 billion years ago. These earliest forms of life were microscopic organisms. But almost a billion years later, some of these organisms would change the course of the world. The Earth did not remain a water world for long. Soon, the first continents emerged from the ancient ocean. Scientists call them cratons. As more and more land rose from the ocean, the first supercontinent appeared on the planet. Volbara wasn't exactly a supercontinent. It was quite small. Scientists believe it was smaller than the continent of Australia. Around 2.4 billion years ago, cyanobacteria evolved to become our planet's first photosynthesizers. Finally, we had oxygen producers that made Earth's atmosphere much more hospitable. And the rest is history, friends. Just kidding. We still have a long way to go. With all this new oxygen, Earth's atmosphere had much lower levels of carbon dioxide. And that caused the planet to become extremely cold. Much of our young world froze when Earth experienced its first ice age. Now, as the Earth's atmosphere was changing, the continents were moving too. They separated and reassembled on the next supercontinent, Rodinia. Rodinia was a true supercontinent. It may have been the largest supercontinent to ever cover the planet. And life? Well, it finally became more complex. But then something happened. Rodinia disintegrated and a new supercontinent formed. This was called Pannotia. Then, between about 540 and 485 million years ago, there was an explosion of new life. This time it was called the Cambrian explosion. And animals that evolved during this period had hard parts on their bodies, like shells or spines. The most famous of all were the trilobites, which had an alien appearance. Around 440 million years ago, the climate suddenly changed and the ocean temperature changed dramatically. The Earth experienced its first mass extinction event. This was the Ordovician-Silurian extinction. And most of the life that had spread across the planet disappeared. Many of these life forms laid the foundation for the ecosystems we have on Earth today. Sometime between 420 and 350 million years ago, the first trees emerged from the Earth, and the first animals also came to Earth. 250 million years ago, the planet was covered by our last vast supercontinent, Pangaea. Unfortunately, it was also during this period that Earth witnessed the largest mass extinction event in our history, known as the Great Extinction. Huge amounts of greenhouse gases and accelerated global warming wiped out about 90% of all species on Earth. However, this mass extinction helped pave the way for the next wave of animal evolution. Between 240 and 230 million years ago, the first dinosaurs appeared. For the next 150 million years, they dominated the Earth. If you had been there, you would have witnessed the gigantic sauropod Argentinosaurus, the largest land animal that ever existed. Or perhaps you would have been chased by one of Earth's largest apex predators, the T-Rex. You would also have witnessed how Pangaea broke up and formed the continents we know today. You may already know where this story is going. 66 million years ago, an asteroid crashed into our planet, right where Mexico is now. It spewed so much debris into the atmosphere that it blocked the sun. This led to devastating climate changes that led to the extinction of the dinosaurs. In the next wave of emerging animals, mammals became more common. About 6 million years ago, the first known humans began walking this world. This species was called Sahelanthropus, although they probably still walked on all fours. 4 million years ago, the first humans began to walk upright. And about 1 million years later, they developed the first known tools, which they used to break things. About 800,000 years ago, things got interesting. These early humans discovered how to control fire, and could now cook food and provide themselves with heat. Their brains continued to evolve, now more rapidly than ever. These humans learned to interact with each other and the world around them in completely new ways. Then, between 40,000 and 15,000 years ago, all other human species besides Homo sapiens became extinct. 10,000 years ago, the Earth saw its first farmers. These previously nomadic humans stopped wandering the planet and finally put down roots. Fast forward significantly, to about 250 years ago, when the Industrial Revolution took place. We are going through important technological, socio-economic and cultural transformations. Rural societies based on agriculture industrialized and became urban societies. Now, it is fascinating to consider how the diversity of humanity can go beyond what we know. In this context, I would like to share an exciting recent discovery that challenges our conventional notions about the human species. Humans have spent quite a bit of time on the planet, while our presence has not always had a net positive effect on the planet. You might be surprised to learn that scientists have just discovered a new human species, and that's not even the best part of the discovery. It challenges everything we know about our origin. What is the new human species, and why is it causing so much excitement among scientists? It is common knowledge that modern humans belong to the species Homo sapiens. However, what is not commonly known is how Homo sapiens appeared on the scene. The long evolutionary path that led to modern humans began with a single step, or more precisely, with the ability to walk on two legs. Sahelanthropus, one of our oldest known ancestors, began the long transition from ape-like mobility approximately 6 million years ago. But Homo sapiens would not appear for another 5 million years. During that time, various human species lived, evolved, and went extinct, mixing and sometimes mating along the way. Their bodies evolved over time, as did their brains and their ability to think, as evidenced by their tools and technologies. Scientists are unearthing ancient bones and stone tools, investigating our genes, and recreating the changing environments that helped shape our ancestors' world and guide their evolution. To better understand how Homo sapiens evolved from these ancient hominid lines, which include modern humans and our closest extinct relatives and ancestors, these lines of evidence point to the origin of Homo sapiens in Africa, although not necessarily at one time and specific place. Instead, It appears that distinct groups of human ancestors evolved physically and culturally in relative isolation until climatic changes in the African terrain led them to occasionally mix and trade, exchanging everything from genes to tool methods. Genetic studies in modern humans help us understand our migrations and evolution. Neanderthals, our oldest close relatives, lived about 430,000 years ago and share a common ancestor with us. There is also evidence of another species called Denisovans in our DNA, although few fossils of them have been found. Homo heidelbergensis, who lived between 200,000 and 700,000 years ago, could be a common ancestor. The fossils show mixtures of modern and primitive features, indicating different anatomical groups at different places and times in history. Fossils found in various locations in Africa show combinations of modern and archaic traits in humans. This suggests that people were dispersed across the continent from early times. Some fossils are classified as Homo sapiens due to their similarity to modern humans, but there are debates over whether they are a separate subspecies. Classifying fossils and determining when fully modern humans appeared remains a matter of debate. Cultural changes in Africa occurred about 300,000 years ago, with the transition to more advanced tools. Although there are fossils similar to modern humans, there are also cases of fossils with archaic features but relatively recent antiquity, such as the skull from the Iwo Eluru cave in Nigeria, which is 13,000 years old. Our ancestors evolved over time, developing more advanced tools and technologies. Millions of years ago they began using stone tools, and then adopted the Acheulean culture approximately 1.75 million years ago. Over time, hunting tools and techniques improved, such as the use of spears about 400,000 years ago. Evidence of different types of tools was also found in various locations, indicating the diversity of evolving human groups. Ancient tools have been discovered in India, suggesting the possibility that early humans migrated out of Africa earlier than previously thought. Additionally, fossil remains have been found on Mount Carmel in Israel, indicating the presence of modern humans between 177,000 and 194,000 years ago along the Mediterranean. Human remains have also been found in Kafsa, Israel, dating between 100,000 and 130,000 years ago, showing a long presence in the region. These discoveries provide evidence of the evolution and dispersal of our ancestors throughout history. Limestone caves with evidence from 80,000 to 120,000 years ago were found in southern China. A 100,000-year-old jaw fossil in Jirandong Cave has archaic features but also resembles Homo sapiens. Teeth that are barely recognizable as Homo sapiens were found in the Daoshan Cave, suggesting that they already lived outside Africa. It is speculated that migrations could have occurred even earlier, even reaching Europe around 210,000 years ago. Another controversial discovery is the skull fragment from Epidamus in Greece, with a possible age of more than 200,000 years. But there are debates about its classification and the accuracy of the dating due to the difficulty of preserving the fossils. Many tribes lived outside Africa, but they are not related to our evolution. Genetic analyses reveal that non-African people trace most of their lineage to a historical migration 50,000 to 60,000 years ago, made possible by changes in the sea and favorable climatic conditions. African migrants may have interacted with more archaic hominids, but their lineage appears to have disappeared or been replaced by later migrations. Throughout history, Homo sapiens was not the only human species. We coexist and interbreed with other hominids, some still unidentified. However, these species disappeared, leaving Homo sapiens as the only representative of humanity. An example is Homo floresiensis, known as the hobbit, a small human species found in Flores, Indonesia, until about 50,000 years ago. Although we do not know their fate, they are not related to modern humans. Neanderthals, on the other hand, were found in Eurasia from Portugal and the British Isles to Siberia. As Homo sapiens became more common in those regions, Neanderthals became extinct about 40,000 years ago. Although some evidence suggests that some survived in places like Gibraltar until 29,000 years ago, traces of them can still be found in the DNA of modern humans today. The Denisovans, mysterious cousins of the Neanderthals, left few identifiable fossils, and their appearance and number of species are still uncertain. Recent studies of the human genome in Papua New Guinea indicate that humans interbred with Denisovans about 15,000 years ago, although this is debated. Many Asians today have between 3 and 5% Denisovan DNA, revealing a shared past. The Dragon Man skull found in China in the 1930s has sparked debate and could change our ancestral history. The skull, believed to belong to a new human species called Homo longa or the Dragon Man, displays unusual features and extraordinary size. At least 146,000 years old, the skull combines ancient and modern traits in the human family tree. This discovery could have a significant impact on our understanding of human evolution. The Harbin skull, known as the Dragon Man, is related to other human fossils in Asia. Its identification and classification generate controversy. It could be related to the Denisovans, a sister group of the Neanderthals, but there are few fossil remains of them. This skull highlights the complexity of our family tree and the importance of understanding our mysterious ancestors. The Harbin skull is well preserved and displays an unusual combination of features. It has a low and wide shape with a high forehead, characteristics of ancient hominids. The tooth preserved in the skull has 3 roots, something unusual in modern humans. However, other characteristics are more similar to our own species, such as delicate, flat cheekbones. The researchers analyzed numerous fossils of hominid skulls, jaws and teeth, using a supercomputer to build phylogenetic trees and determine evolutionary connections. The Harbin skull was placed in a new branch closely related to our species. Some suggest classifying the Harbin skull as a separate species, Homo longa, but there is disagreement over its classification and position in the human family tree. Some argue that distinguishing characteristics could be variations within the same species. The Dragon Man, represented by the Harbin skull, is not considered a definitive separate species. Similarities have been found with the skull of Dali and the Denisovans, an enigmatic group that lived in Asia. A fragmented jaw was recently discovered in Tibet that is believed to belong to the Denisovans, and the Dragon Man is closely related to this jaw. According to the proposed new phylogenetic tree, the common ancestor of Neanderthals and Denisovans diverged from the ancestors of Homo sapiens about 600,000 years ago. Neanderthals spread across Europe and the Middle East, while Denisovans spread across Asia. Although the relations between these groups are close, their resolution is difficult. Genetic analyses are not being carried out on Dragon Man due to the destruction it would entail on the fossil. However, researchers remain cautious and open to new evidence. In short, Dragon Man represents a challenge to the classification and categorization of human ancestors. Their discovery highlights the complexity of nature and the difficulty of clearly defining species. The cold, harsh climate of 146,000 years ago at Dragon Man's location could have contributed to the skull's rugged features, according to the researchers. The isolated environment may also have played a role in the fossil's peculiarities. Complete data and detailed photos of Dragon Man are publicly available, allowing other researchers to further explore this hominid. Additionally, an ancient skull has been discovered in Israel that could be from a separate population of Homo that lived between 420,000 and 120,000 years ago. This population exchanged culture and DNA with surrounding Homo sapiens for thousands of years. The study revealed distinct characteristics in the parietal bone of this person, which differ from both early and modern Homo sapiens. These discoveries raise questions about the diversity and evolution of early humans, and researchers continue to analyze and compare the fossils to learn more. Dragon Man's skull has both archaic and Neanderthal characteristics, distinguishing him from other Homo sapiens. It is suggested that other fossils discovered in Israel could belong to this new human group. The Lady of Tabun, an important specimen, could be related to the Homo group of Nesharamla. This could explain some inconsistencies in their anatomy and suggests early gene flow between Homo sapiens and Neanderthals. Interbreeding between these populations was more common than previously believed. 6,000 stone tools were discovered at the Nesharamla site, created similarly to those of contemporary Homo sapiens. This suggests that Nesharamla's Homo and Homo sapiens exchanged ideas and technology. Remains of animals hunted and consumed at the site were also found, including turtles, gazelles, wild boars and ostriches. In addition, a bonfire was found that demonstrated that the Homo of Nesharamla controlled and used fire in a similar way to Homo sapiens and Neanderthals. The preservation of this bonfire for so long is amazing. Today, it is the oldest intact bonfire ever discovered in nature. What do you think of these newly discovered species? We'd like to hear your thoughts in the comments section below.